Students, welcome to all of you for another online class. So in this class I will discuss about some of the numericals on the solution chapter. So first of all, numericals on the relative lowering of vapor pressure. The first question is, the vapor pressure of pure benzene at a certain temperature is 0.850 bar. A non-volatile solid weighing 0.50 grams is dissolved in 39 grams of the benzene. The molar mass of benzene is 78 grams per mole. The vapor pressure of the solution is found to be 0.845 bar. What is the molar mass of the solid? So here first we have to take what are given. So the given are Pa naught, that is the vapor pressure of pure solvent. Here benzene is the solvent, so Pa naught it is equal to 0.850 bar. Then a non-volatile solid weighing 0.50 gram, that means the weight of the non-volatile solute, that is Wb, is equal to 0.50 grams. It is dissolved in 39 grams of the benzene. So benzene is the solvent here, therefore Wa, weight of the solvent, is equal to 39 grams, and given that is Ma, molar mass of benzene is 78 grams per mole. Then the vapor pressure of the solution is found to be 0.845 bar. So solution vapor pressure ಏನಾಗಿದೆ ಕಡಿಮೆ ಆಗಿರುತ್ತೆ, therefore P is equal to 0.845 bar. Then what is the molar mass of the solid? That is Mb is equal to question mark. So we know that Pa naught minus P divided by Pa naught is equal to Wb into Ma divided by Mb into Wa. So we have Pa naught, P, Wb, Ma and Wa. We have to calculate only Mb. Therefore we have to substitute the values in the equation. Therefore 0.850 minus 0.845 divided by 0.850 is equal to 0.50 into 78 divided by Mb into 39. So that is equals to 0.005 divided by 0.850 is equal to 0.50 into 78 divided by Mb into 39. Then Mb is equal to 0.50 into 78 into 0.850 divided by 39 into 0.005. Therefore if you calculate the whole equation, you will get the answer. The molar mass of the solid is equal to 170 grams per mole. ಸೊ ನಮಗೆ ಇಲ್ಲಿ ಏನೇನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅವನ್ನೆಲ್ಲ ಬರ್ಕೋಬೇಕು ಫಸ್ಟು, ಆಮೇಲೆ ಫಾರ್ಮುಲಾ ಬರಿಬೇಕು, ಫಾರ್ಮುಲಾ ಬರೆದು ಎಲ್ಲವನ್ನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿದಾಗ ಸೊ ವಿ ವಿಲ್ ಗೆಟ್ ದ ಆನ್ಸರ್. ದೇರ್ಫೋರ್ ದ ಆನ್ಸರ್ ಈಸ್ ದ molar mass of the solid is equal to 170 grams per mole. So the next question is also based on the relative lowering of vapor pressure. Calculate the mass of a non-volatile solute, molar mass 40 grams per mole, which should be dissolved in 114 grams of octane to reduce its vapor pressure to 80%. ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಮೊದಲು ಅದನ್ನು ಬರ್ಕೋಬೇಕು. ದೇರ್ಫೋರ್ ಗಿವನ್ Mb is equal to 40 grams per mole, ಅಂದರೆ molar mass of the solute. Mb is equal to 40 grams per mole. Wa, weight of the solute. So weight of the solvent, that is 114 grams. Then vapor pressure of the solution reduces to 80%. Therefore vapor pressure of the solution is equal to 80 and the vapor pressure of pure solvent is equal to 100. Wb is equal to question mark. They are asking calculate the mass of the non-volatile solute. Mass of the non-volatile solute, that is WB is equal to question mark. So mass of the solvent Ma, molar mass of the solvent Ma is equal to, so they are giving octane, no, the formula of octane is C8H18. Therefore 12 into 8 plus 1 into 18 is equal to 96 plus 18 is equal to 114 grams per mole. Then we know that Pa0 minus P divided by Pa0 is equal to Wb into Ma divided by Mb into Wa. 100 minus 80 divided by 100 is equal to Wb into 114 divided by 40 into 114. 114 and 114 get cancelled. So we have 1 by 5 is equal to Wb divided by 40, or 40 divided by 5 is equal to Wb. So 8 is equal to Wb. Hence the mass of the given solute is equal to 8 grams. So ನಾವು ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಗಿವನ್ ಬರಿಬೇಕು, ನೆಕ್ಸ್ಟ್ ಫಾರ್ಮುಲಾ ಹಾಕಬೇಕು. ಸೊ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಸ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್ ಮಾಡಿದಾಗ ವಿಲ್ ಗೆಟ್ ದ ಆನ್ಸರ್. ಸೊ ಆನ್ಸರ್ ಫಾರ್ ದಿಸ್ ಕ್ವಶನ್, that is the mass of the solute is equal to 8 grams. So similar problem, 5.8 grams of non-volatile solute was dissolved in 100 grams of carbon disulfide. The vapor pressure of the solution was found to be 190 mm of Hg. Calculate the molar mass of the solute given the vapor pressure of the pure CS2 is 195 mm of Hg and molar mass of carbon disulfide is equal to 76 grams per mole. So similar to that of first problem. First problem ಯಾವ ರೀತಿ ಇದೆ, ಇದು ಕೂಡ ಅದೇ ರೀತಿ ಇದೆ. ಸೊ ನೀವು ಇದನ್ನು ಟ್ರೈ ಮಾಡಬೇಕು. ಸೊ ಹಿಂಟ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಆನ್ಸರ್ ಈಸ್ 171.09 grams per mole. ನೀವು ಇದನ್ನು ಚೆಕ್ ಮಾಡ್ಕೋಬಹುದು. So next is numericals on elevation of boiling point. So elevation of boiling point ಮೇಲೆ so numericals ನ ನೋಡೋಣ. The first one is 18 grams of glucose, that is C6H12O6 is dissolved in 1 kg of water. Find the boiling point of the solution at 1.013 bars. Kb for the water is 0.52 Kelvin kg per mole. Therefore for this problem the solution is the molecular mass of glucose, that is C6H12O6 is equal to 180 grams per mole. So the number of moles of glucose in 18 gram is equal to weight divided by molecular weight, that is 18 divided by 180 is equal to 0.1 mole. Therefore molality of the solution M is equal to 0.1 mole per kg, that is 0.1 mole per kg. We know that delta Tb is equal to Kb into M, because according to Raoult's law, delta Tb, that is elevation of boiling point, is directly proportional to molality, or delta Tb is equal to Kb into M, where Kb is called molar elevation constant. Therefore delta Tb is equal to Kb into M. We have Kb and M, that is Kb is 0.52 and M is 0.1. Therefore we are getting delta Tb is equal to 0.052 Kelvin. The boiling point of the solution equals to 373.15 plus 0.052 equals to 373.202 Kelvin, because the boiling point of pure water is 373.15 Kelvin, that is 100 degree Celsius or 373.15 Kelvin. Hence the boiling point of the solution equals to 373.202 Kelvin. The next problem is the boiling point of benzene is 353.23 Kelvin when 1.80 grams of non-volatile solute is dissolved in 90 grams of benzene. The boiling point of solution is raised to 354.11 Kelvin. Calculate the molar mass of the solute Kb for benzene is 2.53 Kelvin kg per mole. First of all, we have to write what are the given points. So, given is Tb naught, that is the boiling point of pure solvent, that is benzene, is equal to 353.23 Kelvin, and Wb mass of the solute, that is 1.80 grams, and Wa mass of the solvent, that is 90 gram, and Tb, that is boiling point of the solution, that is 354.11 Kelvin. Kb is equal to 2.53 Kelvin kg per mole, and they are asking Mb is equal to what, that is Mb is equal to question mark. So, we know that delta Tb is equal to Tb minus Tb naught, Tb minus Tb naught. Tb is 354.11 minus 353.23, that is 0.88 Kelvin. ಸೊ ಇಲ್ಲೊಂದು ಹಿಂಟ್ ಕೊಡ್ತಾ ಇದ್ದೀನಿ, ಯಾವಾಗಲೂ ದೊಡ್ಡ ಸಂಖ್ಯೆಯಲ್ಲಿ ಸಣ್ಣ ಸಂಖ್ಯೆನ ಕಳಿಬೇಕು, ಅವಾಗ ನಮಗೆ ಎಲಿವೇಶನ್ ಇನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟು ಸಿಗುತ್ತೆ. ಸೊ ದೇರ್ ಫಾರ್ 354.11 minus 353.23 is equal to 0.88 Kelvin. So Mb is equal to 1000 into Kb into Wb divided by Wa into delta Tb. So that is equal to 1000 into 2.53 into 1.8 divided by 90 into 0.88. If you solve this one, you will get the answer is 57.5 grams per mole. That is the molar mass of the solute. Hence, the molar mass of the solute is equal to 57.5 grams per mole. The next question. Acetone boils at 56.38 degrees Celsius and a solution of 1.41 grams of an organic compound in 20 grams of acetone boils at 56.88 degrees Celsius. Calculate the molar mass of the organic compound. Given Kb for the acetone is equal to 1.67 Kelvin kg per mole. First of all, we have to write the given conditions, that is Tb naught is equal to 56.38 degrees Celsius, Tb is equal to 56.88 degrees Celsius, Wb is equal to 1.41 grams, Wa is equal to 20 grams, Mb is equal to question mark. Again we have delta Tb is equal to Tb minus Tb naught. So that is 56.88 minus 56.38, we have getting 0.50. Delta Tb is equal to Kb into molality, that is Kb into 1000 into Wb divided by Mb into Wa. Mb is equal to Kb into 1000 into Wb divided by Wa into delta Tb. So we have to substitute the values. Kb is equal to 1.67 into 1000, Wb is 1.41 divided by Wa is 20 and delta Tb is 0.5. So by equating this one, we can get the answer, that is the molecular mass of the organic compound, that is equal to 235.47 grams per mole. So ನಾವೆಲ್ಲವನ್ನು ಈಕ್ವೇಟ್ ಮಾಡಿದಾಗ ನಮ್ಗೆ ಬರುವಂಥ ಆನ್ಸರು 235.47 grams per mole. So next is the numericals on depression of freezing point. The first question, addition of 0.643 grams of a compound to 50 centimeter cube of a benzene, the density is 0.879 grams per centimeter cube, lowers the freezing point from 278.66 Kelvin to 278.18 Kelvin. If Kf for benzene is 5.12 Kelvin kg per mole, then calculate the molar mass of the compound. First we should write what are the given. So given is Wb, that is mass of the solute, is equal to 0.643 gram. Wa, that is mass of the solvent, they are giving so ml volume and density. So mass equal to volume into density. Therefore, V into D, that is 50 into 0.879 equals to 43.95 grams. Delta TF is equal to 278.66 minus 278.18 is equal to 0.48 Kelvin. So ಇಲ್ಲಿಯೂ ಕೂಡ ದೊಡ್ಡದ್ರೊಳಗೆ ಸಣ್ಣದನ್ನು ಕಳ್ಕೊಂಡ್ವಿ ಅಂದರೆ so we will get the depression in freezing point. So here it is 0.48 Kelvin, and given that Kf is equal to 5.12 Kelvin kg per mole, then we know that Mb is equal to Kf into 1000 into Wb divided by Wa into delta Tf. If you substitute the values, 1000 into 5.12 into 0.643 divided by 43.95 into 0.48, you will get the answer 156.1 grams per mole. Hence, the molar mass of the compound is equal to 156.1 grams per mole. So, the next question, 31 grams of an unknown molecular material is dissolved in 500 grams of water. The resulting solution freezes at 271.14 Kelvin. Calculate the molar mass of the material given Kf for water is equal to 1.86 Kelvin kg per mole. Freezing point of water is equal to 273 Kelvin. First of all, we have to write what are the givens. So, given Wb is equal to 31 gram, Wa is equal to 500 grams, Kf is equal to 1.86 Kelvin kg per mole, Tf naught is equal to 273, Tf is equal to 271.14 Kelvin, Mb is equal to question mark. First of all, we have to calculate delta Tf. So, delta Tf calculate ಮಾಡಬೇಕು ಅಂದರೆ ದೊಡ್ಡದ್ರೋಗೆ ಸಣ್ಣದನ್ನು ಕಳಿಬೇಕು. 273 minus 271.14, you will get 1.86. So, therefore, Kf is 1.86 into 31 into 1000 divided by 1.86 into 500, you will get 62 grams per mole. So, ಈ ರೀತಿ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿಕೊಂಡಾಗ ನಮಗೆ ಬರುವಂಥ ಆನ್ಸರು 62 grams per mole. Next, the numericals on osmotic pressure. So, osmotic pressure ಮೇಲೆ numericals na ನೋಡೋಣ. First one, 200 centimeter cube of an aqueous solution of a protein contains 1.26 grams of protein. The osmotic pressure of the solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. Calculate the molar mass of the protein. So, first of all, we have to write the given. So, P, that is pi, that is pressure, is equal to 2.57 into 10 to the power minus 3 bar, and V, volume, is equal to 200 centimeter cube or 0.2 liters. ಸೊ ಇಲ್ಲಿ ನಾವು ವಾಲ್ಯೂಮ್ನ ಲೀಟರ್ಸ್ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ, ಯಾಕಂದರೆ ಯೂನಿವರ್ಸಲ್ ಗ್ಯಾಸ್ ಕಾನ್ಸ್ಟೆಂಟು ಲೀಟರ್ ಬಾರ್ ಪರ್ ಮೋಲ್ ಪರ್ ಕೆಲ್ವಿನ್ ಒಳಗಿರುತ್ತೆ. ಸೊ ಟಿ ಈಸ್ ಈಕ್ವಲ್ ಟು 300 ಕೆಲ್ವಿನ್. ಸೊ ಆರ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0.083 ಲೀಟರ್ ಬಾರ್ ಪರ್ ಮೋಲ್ ಪರ್ ಕೆಲ್ವಿನ್. ಅದು ಪರ್ ಕೆಲ್ವಿನ್ ಆಗಬೇಕು, ಬಂದಿಲ್ಲ, ಸೊ ಪರ್ ಕೆಲ್ವಿನ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಡಬ್ಲ್ಯೂ ಬಿ ಈಸ್ ಈಕ್ವಲ್ ಟು 1.26, MB is equal to question mark. So we have pi is equal to WB divided by MB, RT divided by V, but MB is equal to WB into RT divided by pi into V. If you substitute the value, therefore MB is equal to 1.26 into 0.083 into 300 divided by 2.57 into 10 to the power minus 3 into 0.2, you will get 61,039 grams per mole. So we are getting, that is, the mass of the protein is equal to 61,039 39 grams per mole. ಸೊ ಇದು ಈ ರೀತಿಯಾಗಿ ಮಾಡಬೇಕು. ಫಸ್ಟ್ ಏನೇನು ಕೊಟ್ಟಿರ್ತಾರೆ ಅವನ್ನೆಲ್ಲ ಬರ್ಕೊಂಡು ಆಮೇಲೆ ಫಾರ್ಮುಲಾ ಬರೆದು ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಮಗೆ ಸಿಗೋದು ದ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆಫ್ ಪ್ರೋಟೀನ್ ದಟ್ ಈಸ್ MB is equal to 61,039 grams per mole. Next question. If 1.71 grams of sugar molecular mass is equal to 342 is dissolved in a 500 centimeters cube of a solution at 300 Kelvin, what will be its osmotic pressure given R is equal to 0.083 liter bar per mole per Kelvin. First of all, you have to write the given, that is volume 500 centimeter cube. So convert into liters, that is 0.5 liters. Temperature T is equal to 300 Kelvin. R is equal to 0.083 liter bar per mole per Kelvin. WB is equal to 1.71 grams. MB is equal to 342 grams per mole. So pi is equal to question mark. We have pi is equal to WB divided by MB RT divided by V. If you substitute the values, that is 1.71 into 0.083 into 300 divided by 342 into 0.5, you will get 0.249 bar or 2.49 into 10 to the power minus 1 bar. Hence the osmotic pressure is 0.249 bar or 2.49 into 10 to the power minus 1 bar. Next, determine the osmotic pressure of a solution prepared by dissolving 25 mg of K2SO4 in 2 liter of water at 25 degrees Celsius, assuming that it is completely dissociated. ಸೊ ಇಲ್ಲಿ ನಾವು ಕರೆಕ್ಟಾಗಿ ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗತ್ತೆ, ಯಾಕಂದರೆ ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋಂಥ ಸೊಲ್ಯೂಟು ಅದು ಡಿಸೋಸಿಯೇಷನ್ ಆಗುತ್ತೆ. ಹೆನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಲುಕ್ ಎಟ್ ದ ವೆಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್. When K2SO4 is dissolved in water, it gives K plus and SO4 2 minus ions. That is, K2SO4 gives 2K plus SO4 2 minus. Hence, I is equal to 3 and WB is equal to 25 mg, that is milligrams. If you convert into grams, it becomes 0.025 grams. Volume equal to 2 liters and temperature equal to 25 degrees Celsius. If you convert into Kelvin, 25 plus 273, that is 298 Kelvin. We know that R is equal to 0.0821 liter atmosphere per Kelvin per mole. MB is equal to, so we are having K2SO4, therefore MB is equal to 2 into 39 plus 1 into 32 plus 4 into 16 is equal to 174 grams per mole. Pi is equal to I into WB RT divided by MB into V is equal to 3 into 0.025 into 0.0821 into 298 divided by 174 into 2, that is equals to 5.27 into 10 to the power minus 3 atmosphere. So ishtu namagenu barutte answer barutte. So if you substitute all the values, you will get 5.27 into 10 to the power minus 3 atmosphere. So ಈ ಪ್ರಾಬ್ಲಮ್ ಮಾಡಬೇಕಾದ್ರೆ ನಾವು ಸರಿಯಾಗಿ ಸೊಲ್ಯೂಟ್ ಯಾವುದು ಕೊಟ್ಟಿರ್ತಾರೆ ಅಂತ ಗಮನಿಸಬೇಕು. ಒಂದು ವೇಳೆ ಅದು ಡಿಸೋಸಿಯೇಷನ್ ಅಥವಾ ಅಸೋಸಿಯೇಷನ್ ಆಗ್ತಾ ಇದ್ದರೆ ಸೊ ಅಲ್ಲಿ ನಾವು ವ್ಯಾಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್ನ ಯೂಸ್ ಮಾಡಬೇಕು. ಹಿಯರ್ ವ್ಯಾಂಟ್ ಆಫ್ ಫ್ಯಾಕ್ಟರ್ ಈಸ್ 3. ಸೊ I into WB divided by MB RT divided by V. Next, numericals on Van 't Hoff factor, that is, first question, 2 grams of benzoic acid dissolved in 25 grams of benzene shows a depression in freezing point equals to 1.62 Kelvin. molar depression constant for benzene is 4.9 Kelvin kg per mole. What is the percentage of association of acid? It is forms a dimer in solution. So the molecular mass of benzoic acid is 122 grams per mole, C6H5COOH. So Mb is equal to I into Kf into 1000 into Wb divided by Wa into delta Tf. So we have Wb and Mb and Wa and delta Tf. So we have to calculate first the Van't Hoff factor. So therefore 122 is equal to I into 1000 into 4.9 into 2 divided by 25 into 1.62, that is I is equal to 122 into 25 into 1.62 divided by 1000 into 4.9 into 2, that is equal to 0.5042. So Van't Hoff factor I is equal to 0.5042. ಸೊ ಇಲ್ಲಿ ನಾವು ಒಂದು ನೆನಪಿಡಬೇಕಾದ ವಿಷಯ ಏನಂದರೆ, ಸೊ ಯಾವಾಗಲೂ ಅಸೋಸಿಯೇಷನ್ ಆದರೆ ಸೊ ಐ ವ್ಯಾಲ್ಯೂ ಲೆಸ್ ದೆನ್ 1 ಇರುತ್ತೆ. ದೇರ್ ಫೋರ್ I is equal to 0.5042. Next, if alpha is the degree of association, ಸೊ ನಾವು ಡಿಗ್ರಿ ಆಫ್ ಅಸೋಸಿಯೇಷನ್ ಕಂಡುಹಿಡಿಬೇಕು. ಸೊ ಅದಕ್ಕೋಸ್ಕರ ಯಾವ ರೀತಿ ಅಸೋಸಿಯೇಷನ್ ಆಗುತ್ತೆ ಅನ್ನೋದನ್ನು ಸೊ ಈಕ್ವೇಷನ್ ಮುಖಾಂತರ ಬರ್ಕೋಬೇಕು. C6H5COOH, it is in equilibrium, that is half into C6H5COOH twice. ಸೊ ಇಲ್ಲಿ ನಮ್ಮದು ರಿಯಾಕ್ಟೆಂಟದ್ದು ಸೊ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಡಿಮೆ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ದೇರ್ ಫೋರ್ ವಿ ಹ್ಯಾವ್ ಟು ರೈಟ್ 1 minus alpha, ಸೊ ಇಟ್ ಬಿಕಮ್ಸ್ alpha by 2. ಸೊ ಇಲ್ಲಿ ಡೈಮರ್ ಫಾರ್ಮೇಷನ್ ಆಗೋದ್ರಿಂದ ಸೊ ಅದು alpha by 2 ಆಗುತ್ತೆ. I is equal to 1 minus alpha ಪ್ಲಸ್ alpha by 2. ಸೊ ನಾವು ಐ ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಬೇಕಾದ್ರೆ ಇದನ್ನೆಲ್ಲ ನಾವು ಡಿಗ್ರಿ ಆಫ್ ಅಸೋಸಿಯೇಷನ್ನ ತಗೋಬೇಕು. ಸೊ ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 minus alpha ಪ್ಲಸ್ alpha by 2. ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 minus alpha by 2 ಬಿಕಾಸ್ ಸೊ ಇಲ್ಲಿ ಮೈನಸ್ ಅಲ್ಫಾ ಪ್ಲಸ್ alpha by 2 ಅಂದರೆ ಒಂದರೊಳಗೆ ಅರ್ಧ ಕಳೆದ್ರೆ ಉಳಿದಿದ್ದು ಅರ್ಧ ಮಾತ್ರ. ಐ ಇಸ್ ಈಕ್ವಲ್ ಟು 1 minus alpha by 2. ಸೊ that gives I minus 1 is equal to minus alpha by 2. Therefore 1 minus I is equal to alpha by 2. So we have already I value, that is 0.5042. 1 minus 0.5042 is equal to alpha by 2, that is 0.4958 is equal to alpha by 2. Alpha is equal to 0.4958 into 2, that is equal to 0.9916. Therefore the association of benzoic acid in benzene is 0.9916 or 99.16%. The next problem is 0.6 ml of acetic acid having density 1.06 grams density 1.06 gram per milliliter, that is grams per centimeter cube. It is dissolved in 1 liter of water. The depression in freezing point observed for this strength of acetic acid was 0.0205 degrees Celsius. Calculate the Van't Hoff factor and the dissociation constant of the acid, and Kf for water is 1.86 Kelvin kg per mole. ನಾವು Van't Hoff factor ಮತ್ತು ಸೊ ಇಲ್ಲಿ ಏನು ಕಂಡುಹಿಡಬೇಕು, ಡಿಗ್ರಿ ಆಫ್ ಡಿಸೋಸಿಯೇಷನ್ನ ಕಂಡುಹಿಡಿಬೇಕು. ಸೊ ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ದ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಆಫ್ ಎಸಿಟಿಕ್ ಆಸಿಡ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 60 grams per mole and Mb is equal to I into 1000 into Kf into Wb divided by Wa into Tf. But here we have ವಾಲ್ಯೂಮ್ ಇಂಟು ಡೆನ್ಸಿಟಿ. ಸೊ ವಾಲ್ಯೂಮ್ ಇದೆ ಮತ್ತು ಡೆನ್ಸಿಟಿ ಇದೆ, ಸೊ ಅದರಿಂದ ಮಾಸ್ನ ಕಂಡುಹಿಡಿಯಬಹುದು. ದೇರ್ ಫಾರ್ Wb is equal to ವಾಲ್ಯೂಮ್ ಇಂಟು ಡೆನ್ಸಿಟಿ, ದಟ್ ಈಸ್ 0.6 into 1.06. ಸೊ Mb is equal to 60. ದೇರ್ ಫಾರ್ 60 is equal to I into 1000 into 1.86 into 0.6 into 1.06 divided by 1000 into 0.0205. So 1000 get cancelled. So if you equate this one, you will get I is equal to 1.03976, because here it is undergoing dissociation. Therefore Van't Hoff factor must be greater than 1. Therefore I is equal to 1.03976. Next, if alpha is the degree of dissociation of CH3COH, then CH3COH is in equilibrium with CH3CO minus plus H plus. ಈ ರೀತಿಯಾಗಿ dissociation ಆಗುತ್ತೆ. So here the concentration decreases, here concentration increases. Therefore 1 minus alpha gives alpha plus alpha. I is equal to 1 minus alpha plus alpha plus alpha. So minus alpha plus alpha get cancelled. I is equal to 1 plus alpha. Alpha is equal to I minus 1. Therefore alpha is equal to 1.03976 minus 1 is equal to alpha is equal to 0.03976. So number of moles of CH3COH is equal to mass divided by molecular mass. We have volume and density. So mass is equal to volume into density divided by molecular mass. So 0.6 into 1.06 divided by 60, we will get 0.0106. So next we have to calculate molarity of the CH3COH. So molarity is equal to number of moles divided by volume. Here number of moles is equal to 0.0106 and the volume is 1 liter, divided by 1, we are getting 0.0106 mole. So dissociation constant Ka is equal to alpha square into C divided by 1 minus alpha. We have alpha and C, therefore you have to substitute here. So 0.3976 square into 0.0106 divided by 1 minus 0.03976. So if we equate this equation, you will get 1.741 into 10 to the power minus 5. It is constant, it is not having any it is not having any units. So next question is 19.5 grams of CH2FCOH is dissolved in 500 grams of water. The depression in freezing point of water is observed to be 1.0 degree Celsius. Calculate the Van't Hoff factor and dissociation constant for the fluoroethanoic acid. So it is also similar to that of previous problem. So try yourself and get the answer. So thank you for your cooperation. So please subscribe to my channel, and with this I conclude the numericals on solution chapter. So you have many number of problems in different books, so take it and solve them. So one of the problems will ask in the board examination. So thank you once again.